Hi everyone, welcome to dot point F7, which is the new study on dairy and robotic milking. And as you can see here, the study is on robotic milking and the relationship with culling rate in dairy cows. And so this dot point is quite complex, and you actually need to know a lot of stuff for this. You're not going to be able to do it without having read the actual study. So this is the study here. It was published in, I think, 2019, or sorry, 2018. So it's very recent. But if you haven't read this study, you won't be able to do this dot point very well. Just watching this video will not help you too much. You really need to have read it to understand what we're about to talk about. So it's quite short. I've chosen it because it's relatively easy to understand, and yeah, it's not too long. So for this dot point, you really need to understand all of these aspects. So you need to understand how the study was designed. You need to understand the methodology of how it was actually run. You need to understand how they collected the data for it. You need to understand how they presented the data. And then you also need to understand how they analyze the data and what their conclusions and recommendations are. And you'll be able to see here from the past HSC questions that they've often asked large questions on this, such as explaining how the trial was designed, and then how the results might be implemented or led to reliable results being produced. You'll notice here in this one that you had to state a conclusion and a recommendation from this research, and you really need to be able to name the study as well. And then lastly, you have to explain how the design of the research contributed to the validity of its conclusions for 6 marks. And another one here, you need to name the study that you looked at and identify the reasons why they undertook it. And for the 6 mark part here, outline the findings of the research study named and explain how their findings can be used in Australian agriculture. So if we start with breaking the syllabus apart, or actually first let's think about looking at an overview of the study itself. So the abstract in a research report is basically a summary of the entire thing, and it's there so people can kind of skim through it and work out what the study's saying and see if they want to read any further. So basically the study was showing, or was looking at the change of milking from a conventional milking system that involved people to an automated milking system, also known as robotic milking, where it was obviously completely automated by computers and machines and not having human intervention. And so they broke it up into 3 stages. So they chose a number of different farms, which we'll talk about later, but they broke it up into 3 stages. So stage 1 was 2 years before they introduced robotic milking. Stage 2 was 1 year after they introduced robotic milking. And stage 3 was 2 to 3 years after. They're the times that they measured. They measured the production and culling. Culling, of course, means animals that are getting killed. And you've got to remember that in a dairy, each year about 25% of the cows in a dairy are going to get culled or kind of moved on to something else because they're not being productive enough anymore. They're not producing enough milk to be viable financially. So they were looking at the change in culling, different reasons for culling animals, both before they got robotic milking in stage 1, 1 year after they got it in stage 2, and 2 to 3 years after they got it in stage 3. And so they were measuring the time to culling, like how long the cows lasted for, basically. And so the risk of loss here is reasons why they got rid of animals is because they started not producing enough milk in litres per day. So that was low production. They might have had problems with their udders, which can cause issues with milking, of course. Infertility, meaning they're not getting pregnant and therefore unlikely to produce milk longer term. And lameness, which is a variety of conditions with the animal not maybe not being able to walk properly or just not having much energy, etc. There's a few things that can cause lameness that might have led to them being culled or moved on for that reason. Also, another category of was death or emergency slaughter. So sometimes cows just die, or they have to be put down in an emergency, like quickly, because there might be some kind of broken bone or something like that, where they just need to be put down quickly. And so they found that when they moved to robotic milking, the actual chance of death or emergency slaughter decreased. And this was said to be because in a normal conventional system with humans milking, they usually get their rations, say, once a day. But with robotic milking, the robots, when they went to get milked 3 or 4 times a day, they would get a ration, a small amount of feed each time they went to get milking. And so because their feed in the robotic system was spread out throughout the day, there was less chance of dietary issue, which meant less chance of emergency slaughter or death due to problems with digestion. However, they found that there was actually more animals, when they introduced robotic milking, more animals were being culled or slaughtered due to low production and also sick cows. But this was thought to be because robotic milking or AMS is very expensive to install, and so they needed to only have cows that were going to be highly productive to make the money back. So farmers were more likely to slaughter animals with low production in a robotic system in the initial years that the study was conducted. So the introduction of the study says that in an automatic milking system or robotic milking, cows are allowed to decide when they milk and when they go and get milked, and that's usually about 3.5 times a day or so on average for robotic milking, whereas in a herd milked by humans, it's more like two times a day or 3 times a day maximum. Also, they found out that milking frequencies for animals, how much they chose to get milked in a robotic system, was dependent on the social structure, the farm layout, the flooring that they had, the health status of the animals, the stage of lactation, whether it was early or later, and the amount of feed they had, all affected how often they wanted to go and get milked. Also, previous research has shown that robotic milking has no effect on the body condition of the animal long term, so they weren't losing condition by being milked more often. Previous research has also found that higher milk production due to more frequent milking equals lower energy and also lower fertility. So if we look at the actual study that we are looking at here, the first part of the syllabus we have to look at is the design of the study. And so we have to look at control, randomization, standardization, and replication, which is, of course, the 4 principles of design of a scientific experiment. So in terms of control, there were 23 different there was 23 different farms. As you can see here, 23 different farms were used with 71 cows. So that's the replication. And so each farm, they chose farms that had didn't have robotic milking, but then they changed to have robotic milking. And so basically the control was each farm had its own control. So there was 23 different farms, and each farm had its own control. And of course, that control was what the culling rates were before they introduced robotic milking, which is what we call stage 1 or prior to robotic milking. So each farm had its own individual control. For randomization, it's not really directly addressed in this study because there were 23 farms and they measured all of the cows on those farms. So they don't really mention randomization, and it's not really an issue here. And by the way, you really need to have an assessment of the design aspect over here. So you need to write what you think about it, whether you think it's good or bad or whatever, depending on your knowledge of control and randomization and standardization. And so you really need to not sit on the fence here. You need to say, yeah, I think this is really good or bad or whatever, and you need to have a reason for it. So moving on to standardization, farms chosen for the study had only changed milking system. They hadn't changed anything else. So the researchers specifically chose farms that had not changed any other aspects of their farm, only changed to robotic milking. So the actual cows themselves, the rations they were given, the management, all of the other things which were kept the same, and indeed all of the breeds across all of the farms were all Holstein cattle used. As we mentioned before, the replication was that there was 23 different farms used and 71 cows on average in each farm, which is quite good. Moving on to part 2 on methodology of how the study was actually conducted. So as we've already mentioned, the study used 23 dairy farms with an average of 71 cows on each farm. And the data for the survey was taken from farms that were enrolled in what's called the Dairy Herd Improvement Program. So this is a special program in farms in the area of Spain that it was done in. And if they're part of this program, basically they have someone come out to the farm each month and kind of record aspects such as the reason for their culling of animals and slaughter of animals and what's causing it. And so that information is recorded in the Dairy Herd Improvement Program. The farms were chosen for the study, of course, because they were ones that changed from normal milking to robotic milking, and they didn't change anything else. And of course, as we already mentioned, the measurements were grouped into stage 1, which is the 2 years before they went to robotic, stage 2, which is a year after, and stage 3, which was 2 years after AMS. And so you really need to comment on what you think about the validity of this methodology here. The next one, which is the collection of data for the study. So as we mentioned already, there's a bit of overlap here between these sections, but the data was obtained from the Dairy Herd Improvement Program, which was a database that already existed because these farms had been part of that program and in this area of Spain. And so these farms that were chosen were ones that had robotic milking installed between 2009 and 2014. And so, as we mentioned, as part of the Dairy Herd Improvement Program, an inspector visited all of the farms monthly to check up and record the reasons for their death of different animals. And so the data measured here was the reason for the culling. So if it was death or emergent disorder, low production, udder problems, infertility, lameness, or other causes, and also the number of cows that happened to. And so again, you really need to critique here based on your own understanding of the reason, or sorry, just a critique about how they collected the data and whether that was good or bad or whatever. And you need to think about, this was already data being collected. It was collected by a trained person who's an inspector to go out to the farm. So I think it's quite good, but you should talk about that a bit more. When we look at presentation of data here, we have a few different tables. And so if we skip ahead to those, here we have these tables here. So this is table 1 here, and this shows the milk yield, or the amount of liters of milk basically that cows are producing. And you can see here it's in stage 1, which is before robotic milking, stage 2, 1 year after, and stage 3, 2 to 3 years after robotic milking. And so here we have this amount, 10,035 was the average, 10,320, 10,315. And the key thing here is this little subscript or superscript, and this shows that there's a statistical difference. So when animals went from non-robotic milking to robotic milking, you can see it goes from A here to B. That means there is a difference, and you can see here it's higher. Once they move to robotic milking, they actually produce more milk, and that's likely because they're going into get milked more often. And so you can see here, this shows the milk yield or volume produced by cows in each stage, i.e. before and after robotic milking, and production increased in robotic milking. Table 2, on the other hand, here is quite a complex table, and really the key here is the p-value. So a p-value, as we'll say later, if the p-value is 0.05 or less, such as this one, it means there's a significant difference between data. So this shows that, or between groups. So this shows here the information, the stages. So stage 1, stage 2, so before robotic milking, after robotic milking, longer after robotic milking, introduction. And this is the reason for death. So death or emergent disorder, low production, other problems, infertility, other causes, and lameness. And basically, it's a highly detailed table with most of the information from this experiment in this table. And it shows the causes of slaughter, and it tells you whether it changes because of, because of the method of production, such as robotic or non-robotic. And we'll talk about the results after. Table 3 over here is a very complex one, and really you just need to know it says that table showing the intercept of slope of trend lines on a scatter plot. So this doesn't show the scatter plot, it just shows numbers of the intercept and the slope. It's a very confusing table, and so when you're over here writing your advantages and disadvantages of tables, I think you should write what you think about it, but I think table 3 is quite confusing, very confusing actually, and it's probably not super helpful for the average reader. Table 2, on the other hand, is actually quite good, but of course you need to understand p-values, but it has all the p-values in there and all the data, so I think it's quite a good table. And this table up here, table 1, is quite easy to understand and simple as well, so it's quite good. Once we move here to these figures, so here we have figure 1 diagram. So this basically is just 2 cows here. So we've got cow 1, cow 2, and we've got a representation of how data was measured. So this is the second lactation of this cow. So the second time it was pregnant and producing milk, third time it was pregnant and producing milk, fourth time, etc. And it also splits it up by stages, and it shows kind of how the data was recorded, because this only shows cow 1 and cow 2. It doesn't show anything more than that. And so it's just a visualization of how data was recorded, and it only shows 2 example cows and what happened in each stage. It doesn't show summary results of the experiment at all. And this table below is really the same thing as up here, but it's just in text or number format. So that's what it says here. And really, for your advantages, disadvantages, you should write, what you think about it. Is this a good, is this easy for you to understand? Yep, this is a good one. Probably easier to understand for most people than this one. Even though this is showing the same thing, it's, I think, harder to understand for most people. So you should write those things in here. Next, for the analysis of the data, you'll notice that is in this section up here. And sorry, it's further down. And just missed it here. Statistical analysis here. And so this is talking about how they analyze the data in here. And so basically they use this software program called Stata, and it was used to perform an ANOVA, or an analysis of variance. This is the important part. That's used to compare the difference between multiple groups. They also used what's called a Cox model for survival, was also performed. Now, the important part of this is you just need to know what they are and what they're used for. You don't need to understand much more than that. It's not the focus here. It's just that there was analysis done, and this is the important part, that when they did those things, they found out the p-values, or what's known as the statistical significance. So how do we tell if 2 groups of data are actually different enough that they're considered statistically significant, or statistically different, or significantly different? That is done by these p-values. And so basically the tests that they've done up here will tell you these p-values of data, and they'll tell you whether they're significantly different. So when the p-values are less than 0.05, there is a statistically significant difference. And so you need to really write in here an analysis of their methods, but I think honestly you should be saying that it's pretty good, because you can see that they have given p-values here for all the data, and it's quite helpful in the way that they've done it. So they have done a good job of that. Lastly, we move on to the conclusions and recommendations of the study. So what conclusions did the researchers come up with from the study? The first one is that the culling rate, or the number of animals that were killed, did increase overall when robotic milking was introduced. Now, there's 2 different areas of culling. So death and emergency slaughter is like the animal dying on the spot, or having to put it down really quickly because it's suffering. And that actually decreased after robotic milking was introduced. And it's thought that that was because, as we mentioned before, there's less dietary issues, basically, because when robotic milking happens, cows eat their food. They get given a food by the robot every time they go to get milked, 3 or 4 times a day. And so they eat their food more gradually throughout the day, instead of just getting it once a day. When humans are milking them, they give them the ration out. They just get it once a day and probably eat it more quickly. And so it's thought that AMS, or robotic milking, would or has been the cause of that reduction in death and emergency slaughter due to that. So, however, other causes of culling, for example, for low production, because they may be producing 25 litres instead of 35 litres a day now, actually increased. So the number of cows that were killed because they weren't producing enough increased once robotic milking was introduced. And that's thought to be for a couple of reasons. Firstly, with robotic milking, the farmers get a lot more data and information about the number of litres that the cows are producing per day. But also, because robotic milking is very expensive to install, farmers are more likely to kill cows or to cull them because they're not producing as much. Those cows might have been profitable in a non-robotic system, but because they've spent so much money installing a robotic system, they can't afford to have cows that aren't producing much, and they need to get rid of them. That's why that's thought to have increased. So what are their recommendations of the researchers? They really only had one recommendation at the end of the study, which was that further studies could be done beyond the 3-year period. So they only measured after robotic milking was introduced for 3 years. But they're saying that maybe someone could go and do some research after 3 years and see, do the culling rates kind of return to normal of what happened beforehand after robotic milking occur, after 3 years and beyond from robotic milking being installed. And so what things would you suggest could have been changed or done better? I mean, the main ones for me are that the study could have been replicated on much larger herds, such as we have in Australia. I mean, these farms had 71 cows on average, and in Australia we'd have much larger herds. Does that make a difference? We don't really know until someone does some research on it. In different geographic locations, because obviously this was only done in a small area of Spain, and with different breeds of dairy cow, because it was only done on Holsteins. And so what conclusions would you draw from the study? You really need to think here, what do you think could be done differently?